almost certainly that's how the sun and the planets were born. In fact, we're still seeing the life sequences in that story today. Debris still rains down onto the Earth, and comets zoom in from the outer parts of the solar system where the relics of the old gas clouds still stand. And if we look out beyond the solar system, we see that many newly born stars are surrounded by gas clouds of their own, very much like the one which must have surrounded the sun in its early stages. Looking deep into space, we can see the past and future of our own sun. Space is far from empty. All around are gas and dust, the raw materials from which stars can be born. We can see nurseries of infant stars, and the dying remains of once mighty suns. Now we know that the planets of our solar system were born at the same time as the sun, we start to wonder if other stars are born with planets too. But the mysteries of starbirth are hidden from the gaze of ordinary telescopes within huge shrouds of dust. In 1983, a revolutionary astronomical instrument went into orbit about the Earth. RS was an infrared telescope in space, and it saw the universe in a new light. When RS looked at the great dust clouds in Orion, it could see through the dust to a cluster of giant stars being born within. In another dust cloud, it picked up the birth of a single star just like the sun, but too far away to be able to see any detail. That had to wait until RS's infrared eye was turned on the brilliant star VIDA.
And one of the most exciting discoveries by IRAS was, in fact, that stars, host stars like Vega and Beta Pictoris, actually have shells of material, disks of material in orbit around them. Material that might well be the building blocks of planets. The amount of material is fairly hard to pin down, but it's something around a few Earth masses, maybe as much as the mass of the planet Jupiter, in orbit around one of these stars. And we see a faintly glowing heat coming from this star that can only be explained by a shell of material like this.
So RS saw cool matter around Vega, but it didn't look like our idea of a solar system. RS, however, had seen several similar stars, and two astronomers took a closer look at one, Beta Pictoris.
Brad Smith and I decided to follow up on the IRAS result of material around other stars. We used an ordinary telescope and some rather sophisticated ground-based instrumentation to look at Beta Pictoris, one of the IRAS stars, and found it was surrounded by a disk of material, flattened disk, indicating the material was in orbit around the star, something like 10 or 20 times larger in extent than our own solar system.
This is the first picture of the solar system beyond our own. By blocking out the glare from the central star, they were able to see the faint glow of its disk, seen edge on. But what was it made of?
Ice was almost certainly the composition. There may be some rocky material mixed in with it, but it's almost certainly ice, and it is, in fact, almost certainly the very same material that was around the sun 4.5 billion years ago when the planetary system formed.
We're trying to find solar system information.
We are, in fact, saying that it is a solar system, either in formation or actually perhaps already formed. In other words, what we may be seeing is the debris that's left over after the formation of a planetary system around Beta Pictoris.
So we could be planets in there as well?
Yes, there's no direct evidence at this moment one way or the other, except to say that when you have that much material, it's almost impossible to conceive of planets not forming. So the probability, although we can't detect them, is very high that Beta Pictoris is surrounded by planets, and then what we see is this big disk of leftover material that didn't get into the planet formation.
Beta Pictoris is a star which in many ways is very like our sun. What's the possibility of finding these kinds of things around other stars?
Yes, I think that's what's particularly interesting about this discovery. When we start thinking about the possibilities of life elsewhere in the galaxy, in the universe, the question is our own solar system unique? Is it very rare to find a star with planets around it? And we had no idea whatsoever what the answer was to that question. Now we have found another rather nearby star with a disk around it which almost certainly indicates planetary formation. And if there is such a disk around Beta Pictoris, there are undoubtedly many other stars as well, and I would say that star formation or planetary formation go together, and their planets may be very, very common throughout the galaxy. If planets are common, then the possibility of life is very much increased, and it says that there's probably a very good chance that we're not alone in the universe.
It's a long way, though, from seeing a disk of matter around a star to finding an actual planet, a place on which life might exist. The problem is that a planet is small and dark, and it's almost impossible to spot against the dazzling glare of its sun. But astronomers are a resourceful breed. By using infrared, they can turn down the contrast between a planet and its star. Observatory in Arizona, astronomers have equipped one of the largest telescopes with an infrared detector. For years they've been trying to pick out planets circling the nearest stars in space. And finally, with a faint star unromantically named VIDA, they think they've succeeded. For the first time, man may have discovered a planet around another star. And the man is Don McCarthy.
I saw two objects that were close together, about an arcsecond apart, and differing in brightness by a factor of 20 or so in the infrared. VIDA is thought to be one of the lowest possible luminosity stars, right at the limit of what a star is. And so finding another object that close, and yet 20 times fainter than VIDA, already indicates that the two are physically associated, and that the fainter object can't be a star.
Don's infrared camera scanned across the star BB8 in two directions. In both directions, it showed a second blip. It had to be a planet, and it was given an even less romantic name than its sun.
Well, we call it VB8b.
That's boring! Couldn't you come up with something a bit better than that?
I have received a lot of letters from school children all over the country who have very interesting names proposed. Hesperios and Vulcan, and some names have already been used.
Vulcan's a good one.
That's right.
Our own planet, Jupiter, bears many resemblances to VD8b. Both generate their own heat because they're so very massive. It's this telltale heat which allowed the infrared camera to track down VD8b. But we know that planets like these can't support life. Do you hope eventually that you'll find planets like the Earth around other stars?
Well, that's the hope, but it's very difficult to directly detect the light from an Earth-like planet, because there you're not seeing its heat so much as its reflected light. And an Earth-like planet is very small, would not reflect much light. So I think in the immediate future our goals are to detect the heat from larger planets. And the search for Earth-like planets can be accomplished by doing more of the astrometric measurements, where you're not looking at the planet itself, but the motion of the star that gives away the planet. And that's possible from space, too.
The task of finding another Earth circling around a distant star seems almost impossible. It's well beyond today's technology. Even the next generation of telescopes in space will probably only find more gas giants like Jupiter. But the idea of our finding a celestial twin is so enticing that astronomers are unlikely to give up. One day, we may find a whole set of planets orbiting a star, and the future astronomer who explores them will be like Goldilocks, looking for one that's not too big, not too small, not too hot, and not too cold, but just right. With air and sea and land and maybe life.